Hi, so we're working 235, 236, and 237. 235, this page says, write the multiplication and division fact families for the numbers. Let me get a little bit zoomed in here so we can see better. So our goal here is to make 4 problems using those 3 numbers each. So we'll start with our multiplication problems. And then use your product from the multiplication problems, turn it into the dividend for your division problems. Same thing over here. Start with your multiplication problems. And then switch to your division problems. Same thing for problems 3 and 4. Pause the video and work the problems first if you haven't already, and then check with my work. Switch and make your division problems. Next page is about divisibility rules. So use the divisibility rules in the table. So if it's even, it can be divisible by 2. So 270 is even. So yes, divisible by 2. We can divide a number evenly by 3 if we can add its digits and divide that sum by 3. So if you add 2 plus 7 plus 0, it equals 9. And 9 divided by 3 is 3. So that's divisible by 3. So I'm reading for 5. We can divide a number evenly by 5 if it ends in 5 or 0. 270 ends in 0, so it's divisible by 5. For 6, we can divide a number evenly by 6 if we can divide it evenly by 2 and by 3. So since 270 was divisible by 2 and by 3, it's divisible by 6. And we can divide a number evenly by 10 if it ends in 0. 270 ends in 0. Okay, so let's check these other ones. $555. Is it even? No, it's not even. So it's not divisible by 2. No. Okay. We can divide a number evenly by 3 if we can add its digits and divide that sum by 3. So 5 plus 5 plus 5 is 15. 15 divided by 3 is 5. So yes, that's divisible by 3. Is it divisible by 5? If it ends in 5, 555 ends in 5, so yes, it's divisible by 5. It is not divisible by 6 because it doesn't have Y is for yes, N is for no. It's not an even number, so it's not divisible by 6. And it's not divisible by 10 because it doesn't have a 0. So that one should just be 3 and 5. Okay, look at 78. Let's clean this side off here and this here. 78 is even, so yes, it's divisible by 2. 7 plus, let's check 3. 7 plus 8 is 15. 15 divided by 3 equals 5, so yes, it's divisible by 3. It does not end in 5, so it's not divisible by 5. It is even, and So it's divisible by 6 if it works with both 2 and 3, and it does. So it's also divisible by 6. It does not end in 0, so it's not divisible by 10. Okay, 393. Let's check it. It's not even, so it can't be 2. Let's add 3, 9, and 3, and what do we get? 3 plus 9 plus 3. 3 plus 12 equals 15. 15 divided by 3 is 5. Used a lot of 15s, didn't they? So yes, this is divisible by 3. It's not divisible by 5. Not divisible by 6 because it's not even, and it's not divisible by 10. So 100. 100 is divisible by 2. It's even. Is it divisible by 3? Let's check. 1 plus 0 plus 0 equals 1. 1 divided by 3, not even. Not divisible. Okay? Is it divisible by 5? Yes, it ends in 0. It doesn't divide by 6 evenly because it doesn't divide by 3 evenly. It does divide by 10 evenly. Okay, 666. It's even. 6 plus 6 plus 6 is 18. 18 divided by 3 is 6. So yes, it's divisible by 3. It's not divisible by 5. Because it's divisible by 2 and 3, it is divisible by 6, and it's not divisible by 10. So let's cross out numbers that are not prime based on divisibility rules. So we know all of the even numbers are not prime. We know all of the numbers that end in 5 are not prime. And now we get to start working on those 3's. So is 501? 5 plus 0 plus 1. That equals 6. 6 is divisible by 3. So 501 is not prime. It's composite because it's divisible by 3. So if we count by 3's from there, then we're good. So 501 plus 3 is 504. 504 plus 3 is 507. 507 is 510. Add 3, you get 13. Add 3, you get 16. Add 3, you get 19. Add 3, you get 22. Add 3, you get 25. Add 3, you get 28. Add 3, you get 31. Add 3, you get 34. Add 3, you get 37. Add 3, you get 40. Add 3, you get 43. Add 3, you get 46. Add 3, you get 49. Add 3, you get 52. And then 55, and 58, and 61. 64, 67, 70, 73, 76, 79, 82, 85, 88, 91, 94, 97. So those numbers that we crossed out are composite numbers. Let's check that next page. What is the area? So we are going to look at a grid and find the area of the gray center. The drawing on the grid shows a section of a design on a tile floor. The pattern shows white and gray sections. What is the area of the gray center part of the pattern? Okay, so the area of the gray center part, let's cut this off, this, and this. So we know that this has an area of 3, this has 3, this has 2, this has 2. And then this has 1, 2, 3, 4, 5, 6. 6 plus 2 is 8, plus 2 is 10, plus 3 is 13, plus 3 is 16. So 16 units squared. What is the area of the entire tile, the gray and the white sections combined? So we already know that this is 16, the gray on the inside, so 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. 38 units squared, and we're squaring it, remember, because it's a measurement of area. An area has length and a width, just like a square has a length and a width. What is the area of just the white border? So we know that this whole thing is 38. So let's take away the 16 from the center, from the gray center. Get 2 there and 2 there. So the white border is 22 units squared. How do we use area formulas to find the area of the white border? So we know that the area of the white and gray, we can subtract the gray to get the white. Thanks for watching.